Hey guys, you should have just watched the video on transcription. And just a reminder of what transcription is, that literally means to write. And it's the process of DNA being copied into an RNA molecule, which can then leave the nucleus, travel through the cytoplasm, and find a ribosome. And ribosomes, you should remember from our unit on organelles, are what make proteins. And that's really important because proteins are what makes you. Your hair color and how tall you are and everything like that is actually determined by proteins. So what that's going to look like, we're going to go ahead and pop right here. This is showing both. So this entire thing is kind of just giving you a snapshot of what would be happening. This dark circle here is to indicate the nucleus, and inside of the nucleus we have this DNA molecule. It's opening up this little bubble. That RNA polymerase molecule is reading this information and creating an RNA molecule. And that's what this looks like here. It kind of looks like a little bit of a ribbon. And we actually are going to call that mRNA, which stands for messenger RNA. Once that happens, it's going to leave the nucleus, travel through the cytoplasm, and find a ribosome. And a ribosome has two units, a smaller unit and then a larger unit. And basically those just kind of clamp on to the mRNA molecule. And that rRNA, we're going to go ahead and call that the rRNA, which stands for ribosomal RNA. And what it does is it's sitting there holding on to the mRNA, which is the messenger RNA, and it's reading it. But it's not doing the reading. It actually brings in this third type of RNA called tRNA, and that T stands for transfer. What it does is it reads this information on the mRNA strand 3 at a time, and we call those 3 a codon. And every single codon stands for or is to represent an amino acid. So let's kind of get a little closer look at what that looks like. So right here, this tRNA kind of looks like a silly little shape, and it's bringing it down. So if it was to read on the mRNA strand UCG on the mRNA strand, then on tRNA it would bring an exact complement or opposite to it, and it would bring a UGC, which in this case reads for this amino acid right here, TYR, and then it's going to go ahead and drop that off. So these ones that have previously been dropped off have been left by the tRNA molecules before that have read further on in the strand that's already been broken off. Just to review our 3 types of RNA, we've got the messenger RNA. That carries the instruction for DNA to be made into copies. Then the transfer RNA, that carries an amino acid to the ribosome, reading it 3 at a time. We call those 3 a codon. And then finally the ribosomal RNA, which is kind of like the kitchen that is making sure that all of this is happening. A codon being the 3 at a time that it reads. These little, they kind of come down, they stamp onto it, read the information, leave behind an amino acid. And that anticodon is the information that's on the tRNA. So we're going to practice a little bit. This chart right here is an amino acid chart. And so what you'll see is if I was to read AUG, then that would represent, you'll look right here for the first letter and go to this row for A. And then the second letter, see right here, then you'll go to the column G, and then you'll find AUG, which right here says MET. That stands for methionine, and that indicates where to start the protein. So every single time it reads methionine, it's going to indicate to be the beginning of that protein. And if I was to read UAA, I'm going to come up here in my first row, second letter right here, and then another one. UAA stands for stop. At that point, once it reads it, it's going to go ahead and cut it off. So what we're going to have you guys do is review the 3 types of mRNA, tRNA, and rRNA. And then I also want you to work on creating an analogy of the dRNA, mRNA, cytoplasm, this should say rRNA, sorry, tRNA, codon, and anticodon, and how it might be kind of like a kitchen or using a recipe.